Okay guys, so on the other video I compared both methods. I'm going to compare both methods one more time right here. Now right here we do have a cube root, okay? A cube root, so we want perfect cube numbers. You could make this list on your own. You could say 2 cubed is 8, 3 cubes 27 with the calculator, 4 cubes 64, and so on and so on. Now 162 is not a perfect cube number. What you want to do is rewrite it with multiplication so you could get one of these perfect cube numbers. So what to do is to take 162 with the calculator and divide it by one of these. 162 divided by 8, it might work. 162 divided by 27. And as you can see, I did it on my calculator. 162 divided by 27 is 6. So what that tells us is that I could rewrite, look, the -3, I'm just going to put it out here in the front. And then the cube root of 162, that 162, I'm going to rewrite it as 27 times 6. Let me do it in a different color. 27 times 6. That way I could split the cube root. And when I split the cube root of 27 is what? The cube root of 27 is what? 3. So I have this outside -3 times that 3, no more, it's not in the radical anymore. And the cube root of 6 is still going to be the cube root of 6. Because there is no number that you could multiply with itself 3 times that gives you 6. Now, let's look at the other terms, guys. Remember, the cube root is really the power of 1/3. So what does that mean? We love to have variables that have exponents that are divisible by 3. If it were a square root, I would love a 4 or an 8. But it's a cube root. Because it's cube root, you want it to be divisible by 3. So what is the cube root of x to the 9th? And you know what? Let me show my work here. The cube root of x to the 9th. What is the cube root of x to the 9th? That is x to the 3rd, no more radical, right? Why? Because 9 divided by 3, that's just 3. So x to the 3rd, no more radical. Now over here, let me get the calculator out of the way. Over here, we have a slight problem. Y to the 4th. We want it to be divisible by 3. That's a 4. It's not divisible by 3. So what I'm going to do is I'm going to rewrite it. Yeah, I'm going to split it. I'm going to rewrite it as y to the 3rd times y. So I'm going to take that y to the 4th and rewrite it as y to the 3rd times y. Why would I do that? So I could split the 3rd root to each of them. And I could actually do, what is y to the 3rd? I mean the 3rd root of y to the 3rd. That's just y, right? Because it's really saying this exponent divided by 3. 3 divided by 3 is 1. So you really just have a y right there. No more radical. And the cube root of y, is going to stay the cube root of y. So there's our answer. All we need to do is simplify and organize it. So my answer will be -3 times 3. That is a -9. And then I'm going to put all the nice values that are outside the radical right next to it. -9 x to the 3rd, y. And then I'm going to put the leftover radicals together underneath one common radical. So I'm going to put the 3rd root of 6y. And ladies and gentlemen, that is your answer for that question. What do you think? Is it challenging? Yeah. Yes. The more you practice, the easier it gets. These exact questions are coming out on the test, guys, so please pay attention to all the videos that I make this week. Let's take a look at the next number. The same number, but we're going to do it with the factor tree. Whoops. So let's start by just breaking down 162. Let's not forget about the -3 that's out here in the front. I'm just going to put it there. But 162, let's start breaking it down. I want to go 2 times, what is half of 162? What's half of 162? 81, okay. And then 81 could be broken down to what? 9 times 9. And then 9 could be broken down to what? 3 times 3. And 9 could be broken down to 3 times 3. And that's as far as we could break things down, right? So since I have a cube root, I need I need groups of 3. So for each group of 3, that comes out of the cube root. So if I were to get these 3 times 3 times 3, I'll pull them out. It's going to be one single 3 on the outside. One single 3 on the outside, and then we have the cube root, and let's see what's left over on the inside. What is left over on the inside? Well, we still have this 2, and we still have this 3. So multiply them on what's left over on the inside? 6. So far, we have this group of 3 that's out there as 1, 3. Let's not forget about that negative 3 that's out here. Let's bring it down. Yeah, we're going to multiply it. But we still have values inside the cube root. Remember, cube root is like dividing by 3. So right here, x to the 9th, that's really going to become what? X to the 3rd, because you're dividing by 3. And it's outside the radical. It's not, there's no more radical in there. So the x to the 3rd is going to have to be squeezed in out here, right here. Okay? And of course, I'll do that when I rewrite my answer. But the cube root of y to the 4th, again, you have to do that same work. Y, you want it to be divisible by 3. So you're going to rewrite y to the 4th as y to the 3rd times y. That way, when you split the 3rd root, you could actually divide by 3. And you will get y on the outside and cube root of y on the inside. Okay? So we have our answer. We just need to organize it. What is negative 3 times 3? That's negative 9. Let's not forget about this x to the 3rd that we're trying to squeeze in there. And we also have a nice y on the outside. And we have the radicals that we're going to put together. We're going to put the cube root of 6 and the cube root of y together. So that's going to be the cube root of 6y. Is it challenging? Either way, yes it is. But the more you practice, the easier it gets.